Craftsman Days are here at Lowe's with big savings on the tools you need. Right now, get a free select tool when you buy the Craftsman V20 2-pack battery kit. Whether it's the backyard, the bathroom, or beyond, Craftsman has the tools to help you power through and get the project done right. Because DIYing is unpredictable, but your tools shouldn't be. Shop Craftsman at Lowe's today. Valid through 6/18 while supplies last. Selection varies by location.
This is SpaceTime, Series 28, Episode 66, for broadcast on the 2nd of June 2025. Coming up on SpaceTime, finally a possible resolution to ongoing debate over the Hubble constant. New data suggests that Venus's crust is surprisingly thin, and targeting the building blocks of stellar formation. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New data from the Webb Space Telescope may finally have found a solution to the long-standing debate over the universe's rate of expansion, a figure known as the Hubble constant. For the past decade, scientists have been trying to get to the bottom of what seemed to be a major inconsistency in the universe. The universe has been expanding out ever since the Big Bang 13.82 billion years ago. And that rate of expansion, that is how fast the universe is moving, is known as the Hubble constant. The problem is that figure is different depending on how you measure it, whether you're looking at it through cosmic history or back from the present day. It was always thought that as measurements got better and more accurate, the differences between the two figures would gradually narrow down. But in reality, the opposite seems to have happened. The more precise the data got, the bigger the gap grew. And it's become a major problem in science's understanding of the universe and its evolution, with more than 1,000 papers published so far, all trying to find a solution. But now, new observations using data from the James Webb Space Telescope may well finally have solved the problem. The study's lead author, Wendy Friedman from the University of Chicago, says the new evidence from Webb suggests that the standard model of the universe is holding up. Now, it doesn't mean we won't find things in the future that are inconsistent with the model, but for the moment at least, the Hubble constant doesn't seem to be a problem after all. Okay, so what are we actually talking about here? Well, there are currently two major approaches to calculating how fast our universe is expanding. The first measures the cosmic microwave background radiation. That's the leftover heat from the Big Bang itself. That radiation, now cooled down to 2.7 degrees above absolute zero, can still be found today as the white noise you hear between stations on old analog radio and TVs. And it tells astronomers what the conditions were like 380,000 years after the Big Bang, when the universe cooled down enough for protons and electrons to come together and form the first atoms. The second approach is quite different. It measures the universe's current rate of expansion using standard candles such as Type 1a supernovae, which can act as cosmic distance markers. Because of the conditions that cause them to go supernova, these stars always explode with the same level of luminosity, regardless of distance. So, like a row of streetlights on a road, you can tell how far away they are by their apparent brightness, using the inverse square law. So if we know the maximum brightness of these supernovae, measuring their apparent luminosities allows us to calculate their distance. And the further away something is from us, the faster it's moving. So additional observations tell us how fast the galaxy in which the supernova occurred is moving away from us. Friedman's also pioneered two other methods that use what we know about two types of old stars, red giants and carbon stars. However, there are many corrections that must be applied to these measurements before a final distance can be declared. For example, scientists first need to account for cosmic dust that permeates the universe and it dims the light between us and these distant stars in their host galaxies. And astronomers also need to check and correct for luminosity differences that can arise over cosmic time. Finally, subtle measurement uncertainties in the instrumentation used to make these measurements also need to be identified and corrected for. But with technological advances such as the launch of the much more powerful Webb Space Telescope in 2021, scientists have now been able to increasingly refine these measurements. Friedman says astronomers have now more than doubled the sample of galaxies being used to calibrate supernovae. The statistical improvements from this is significant and considerably strengthens the result. And this is where we get to the nitty-gritty. According to Friedman's latest calculations, reported in the Astrophysical Journal and which incorporates data from both the Hubble and Webb Space Telescopes, we can now give the Hubble constant a value of 70.4 kilometres per second per megaparsec, plus or minus 3%. And that brings the value into statistical agreement with recent measurements from the cosmic microwave background radiation, which places the constant at 67.4 kilometres per second per megaparsec. The thing you've got to remember is that Webb has 4 times the resolution of Hubble, and that allows it to identify individual stars previously detected in blurry groups. It's also about 10 times as sensitive as Hubble, which provides higher precision and the ability to find even fainter objects of interest. Friedman says astrophysicists have been trying to come up with a theory that would have explained different rates of expansion as the universe ages. And scientists are still trying to find cracks in the standard model that describes the universe, which could provide new clues about the nature of 2 big outstanding mysteries of the cosmos, namely dark matter and dark energy. But at least for now, the Hubble constant increasingly seems not to be the place to look. This is SpaceTime. Still to come, new data suggests that Venus's crust is surprisingly thin and locating the building blocks of stellar formation. All that and more still to come on SpaceTime. Okay, let's take a break from our show with a word from our sponsor, Insta360. Get ready to capture the universe like never before with Insta360, the undisputed champions of 360-degree cameras. Their latest masterpiece, the Insta360 X5, is here to blow your mind with features that make every shot out of this world. First up, there's the X5's invisible selfie stick. It creates those jaw-dropping third-person angles and those drone-like follow shots that'll have everyone asking how you did that. See, the selfie stick vanishes from your 360-degree footage, leaving pure magic. There's no such thing as magic. Well, there is with Insta360. Pair that with the ability to shoot first and point later. Record everything in stunning 8K, then use the Insta360 app's AI-powered reframing tools to pick the perfect angles for that perfect shot, all after the fact. It really is like directing your own sci-fi blockbuster. And with flow state stabilization and 360-degree horizon lock, your footage stays buttery smooth, no matter how wild the action gets. Built like a spaceship, the X5 is Insta360's toughest camera yet, with replaceable lenses made from super strong optical glass and IP68 waterproofing down to 49 meters, perfect for those underwater cosmic vibes. Plus, that massive 2,400 mAh battery keeps you rolling for up to 185 minutes in endurance mode. Now, to bag a free 114cm invisible selfie stick worth $24.99 US with your Insta360 X5 standard package purchase, head to the store insta360.com and use the promo code SpaceTime, available for the first 30 standard package purchases only. That's insta360.com and use the promo code SpaceTime. And for more information, check out the links in our show notes. And now, it's back to our show. A new study suggests that the crust of the planet Venus is unusually thin, and this new model of the Venusian crust has come up with some surprises about the planet's geology. Scientists always expected that the outermost layer of Venus's crust would grow thicker and thicker over time, given its apparent lack of forces that would drive the crust back into the planet's interior. But the paper, published in the journal Nature Communications, proposes a crust metamorphism process based on rock density and melting cycles. Now, the Earth's crust is made up of massive slabs that slowly move, forming folds and faults in a process known as plate tectonics. Material rises from deep within the mantle through convection until it reaches the surface. It then spreads out across the surface in these massive plates. And when 2 plates collide, the lighter plate slides on top of the denser one, forcing the denser one downwards back into the mantle. And this process, known as subduction, helps control the thickness of Earth's crust. The rocks making up the bottom plate, the heavier plate, also experience changes caused by increasing pressure and temperature as the plate continues to sink deeper and deeper back into the mantle. These changes are known as metamorphism, and it's also one of the causes of volcanic activity. Now, in contrast, Venus is a crust that's all in one piece. There's simply no evidence of subduction caused by plate tectonics as we see on Earth. Modelling determined that Venus's crust is about 40 kilometres thick on average, and at very most 65 kilometres thick. Now, by comparison, Earth's continental crust, that's the lighter crust, is between 25 and 70 kilometres thick and mostly composed of less dense, more felsic rocks such as granite. However, in some places, such as the Tibetan Plateau, the Altiplano and the Eastern Baltic Shield, the continental crust can be up to 80 kilometres thick. On the other hand, Earth's oceanic crust is just 5 to 10 kilometres thick, composed primarily of denser, heavier mafic rocks such as basalt, diabase and grabo. One of the study's authors, Justin Filberto from NASA's Johnson Space Center in Houston, Texas, says Venus's crust appears to be surprisingly thin given conditions on the planet. It turns out that, according to this model, as the crust grows thicker, the bottom of the crust becomes so dense that it either breaks off and becomes part of the mantle or gets hot enough to melt. So, while Venus doesn't have any moving plates, its crust does experience a form of metamorphism. Now, if this new model is correct, the findings would be an important step towards understanding geological processes and the evolution of the planet itself. Filberto says this breaking off and melting can put water and elements back into the planet's interior, thereby helping drive volcanic activity. He says it gives scientists a new model for how material returns to the interior of Venus and another way to make lava and spur volcanic eruptions. In a sense, it's sort of resetting the playing field for how the geology, crust and atmosphere on Venus all work together. Of course, the next step is to gather direct data about Venus's crust in order to test and refine these models. And there are several upcoming missions about to do just that. These include NASA's Da Vinci and Veritas spacecraft and the European Space Agency's Envision mission, and combined they'll aim to study the planet's surface and atmosphere in far greater detail than ever before. These efforts could help confirm whether processes like metamorphism and recycling are actively reshaping Venus's crust today, and they could reveal how such activity may be tied to volcanic and atmospheric evolution. Filberto says scientists don't actually know how much volcanism is happening on Venus now. They assume it's a lot. In fact, a lot of scientists believe Venus is probably the most volcanic planet in the solar system. Only the Jovian volcanic moon Io is more active. But to know for sure, scientists need more data, and that's where these missions come in. This is SpaceTime. Still to come, locating the building blocks of stellar formation, and later in the science report, confirmation of a new type of plesiosaur. All that and more still to come on SpaceTime. A new study has shown how stellar formation isn't just based on how much gas there is in a galaxy, but also where that gas is located. Astronomers made the new observations by studying gas distribution in thousands of galaxies as part of the Wallaby survey. Wallaby is being undertaken by ASCAP, the Australian Square Kilometre Array Pathfinder telescope, located at the Murchison Radio Astronomy Observatory in outback Western Australia. The study's lead author, Siona Lee from the University of Western Australia node of the International Centre for Radio Astronomy Research, says the findings give new insights into how stars are born from clouds of gas. She says while earlier surveys could only map gas distribution in a few hundred galaxies, the Wallaby survey successfully mapped atomic hydrogen gas in a significantly larger sample. Atomic hydrogen refers to an isolated hydrogen atom consisting of a single proton nucleus orbited by a single electron. Now, typically, hydrogen exists in molecular form as diatomic molecules comprising two atoms. But under the right conditions, such as high temperatures or during some chemical reactions, these molecules can be split up into individual atoms, resulting in atomic hydrogen. The new findings, reported in the publications of the Astronomical Society of Australia, show that having more gas in a galaxy doesn't automatically mean it's going to be creating more stars. Instead, galaxies that are forming stars usually have higher concentrations of gas in areas where stars reside. Lee says she was excited to see a correlation between star formation and exactly where the hydrogen gas is located. The higher resolution observations available through ASCAP's 36 parabolic dish array allowed Lee and colleagues to measure the location and density of atomic hydrogen for an unprecedented number of galaxies. Understanding how stars form requires astronomers to measure the atomic gas in the areas where stars are actually forming, rather than simply considering the total gas content of the galaxy, which also includes the unused gas in outer regions of the galaxy. The research showed that being able to conduct more detailed radio observations is key to helping scientists understand how galaxies grow and change over time. The authors looked at radio waves and visible light from nearby galaxies to determine the amount of gas in the parts of the galaxy where the stars are being born. And this was important for figuring out just how much gas is really supporting the creation of new stars.
Wallaby survey is an ongoing whole sky survey which observes atomic hydrogen gas of over 200,000 galaxies eventually in all southern hemisphere.
And you're using the ASCAP Australian Square Kilometre Array Pathfinder telescopes.
Yes. Its advantage is a large field of view, so it can observe a large field of sky in a short time. So Wallaby takes an advantage of it. So it observes whole sky in quite a short time with a relatively good resolution.
And this resolution has allowed you to look at the gas inside different galaxies and study these nebulae closely and look at how that leads to star formation. What have you found?
So we analyzed the distribution of atomic hydrogen gas for 1,000 galaxies used from Wallaby survey. And we compared atomic hydrogen gas in the star-forming region and atomic hydrogen gas in the outer part, which is star-forming quiet region, and then found that gas in the star-forming region is more related to star formation in galaxies.
Now, you talked about atomic hydrogen, and when atomic hydrogen gets with friends with other atomic hydrogen atoms, then they, over time, they can cool down. When they cool down, they slow down, and when they slow down, they can bunch up and eventually form a point of intense gravity, which causes the surrounding gas to collapse. Is that what's going on?
So basically, there is atomic hydrogen, and then when it cools down, and it can when there is a gravity, it can combine, and then it becomes more complex molecule like hydrogen molecule. Atomic hydrogen gas is normally broadly spread in the galaxy. So inside there is a star near the center. There is a star-forming region, like concentrated, that we observe as a galaxy disk. And then in the outer part, atomic hydrogen gas is broadly distributed. And the atomic hydrogen gas outside the optically thin stellar disk, then it's too stable to be collapsed and to form stars. So what I focused on is atomic hydrogen gas in the region on the top of stellar disk. So that's what I studied.
Is what you're saying that you've found atomic hydrogen everywhere, all over a galaxy, but there are some areas where it's more concentrated and stellar formation's only happening in those areas?
Yeah, so star formation is concentrated near the center of the galaxy. So I focused on that part and then found the gas density there is essential for that galaxy to form stars.
And is this true of all galaxies or only spiral galaxies, or what was the distribution like?
So what I'm targeting is whole kinds of galaxies, and that's what is important. It's not only certain type of galaxies, but any type of galaxies to form stars, they need gas, and that gas has to be in the right place to form stars.
Did you find atomic hydrogen in sufficient quantities and densities to make stars in elliptical galaxies as well, or are they just old, dead and red?
Good question. So as you said, elliptical galaxies they have less star formation. But of course, there is a star formation, and they have less gas, so it's hard to detect. But if we can observe it, so right now, using ASCAP telescope, Wallaby is observing many number of galaxies to study the evolution of galaxy, evolution of the universe. But in the near future, there's gonna be SKA telescope, which will even detect more faint and more distant galaxies, and it will with a much higher resolution. So these are going to be very helpful to unveil questions about galaxy evolution in the near future.
That's Yona Lee from the University of Western Australia node of the International Centre for Radio Astronomy Research. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Swedish and American scientists have found a link between autism spectrum disorder and a future risk of developing Parkinson's disease. A report in the Journal of the American Medical Association looked at data from over 2.2 million people, finding that Parkinson's occurred in just 0.02% of people who didn't have autism, but it occurred in 0.5% of people who did have the condition. Now, while this kind of research can't prove that being on the spectrum will directly affect your chances of developing Parkinson's, the authors say there might be a potential shared base between neurodevelopmental disorders and Parkinson's disease. A new study claims that amber deposits found in ancient deep-sea mud samples in Japan may be one of the oldest known records of a tsunami. The findings, published in the journal Scientific Reports, shows that large fossilised tree resin deposits, discovered in a quarry on Hokkaido Island in northern Japan, were swept out from a forest to what was then an ocean by one or more tsunami between 116 and 114 million years ago. Looking closely at the amber, the team found that some of it wasn't fully hardened at the time it was caught up in the tsunami, and that suggests that huge amounts of amber were being rapidly carried out from land to the ocean by the backwash from one or more tsunami events. The thing is, traces of ancient tsunamis are hard to find, so amber formed on land and then transported out into the sea could provide a new way of identifying them. A small group of 85-million-year-old fossils, including the official fossil emblem of British Columbia, have now been scientifically described as a new type of plesiosaur. A report in the Journal of Systematic Paleontology claims the fossils which were first discovered on Vancouver Island back in 1988 likely all came from one type of elasmosaur plesiosaur, which is now being named Truscosaurus sandrae. The new classification includes the description of 36 well-preserved clavicle vertebrae, indicating at least 50 neck bones. Truscosaurus lived during the age of the dinosaurs, in the Cretaceous period. Paleontologists say the long-necked marine reptile reached lengths of 12 metres and featured sharp and heavy teeth, along with an odd mix of primitive and newer traits. And unlike other elasmosaur plesiosaurs, its unique suite of adaptations enabled it to hunt prey from above. It's in the back of most bathroom medicine cabinets, right next to the calamine lotion and behind that old packet of Band-Aids. We're talking about that famous blue jar of Vicks VapoRub. It's been with us for over a century now as an ointment to rub on the body to relieve coughs, congestion and minor arthritic pains. But Tim Mendham from Australian Skeptics says people are now claiming you should be rubbing it on your feet.
Vicks VapoRub. We probably all had a whack of Vicks VapoRub on our chest at some stage. But yeah, stick it on your chest. When you're a kid, you have a breathing problem and the fumes get up your nose, etc. It's camphor, it's eucalyptus oil, it's menthol, and it's something called petrolatum. And it's an international product. All those things come from different places, including eucalyptus oil from Australia. And this was the formulation. Made it smelly. Stick it on your chest and do your pajamas back up, etc. And you'll breathe it in all night and you'll have a clear nose and you'll be able to breathe easily. Yeah, this is extended into other areas. Now it's suggesting that you put it on your feet. And this is sort of like a version of reflexology. You massage the foot and that will affect other parts of your body. Stick the VapoRub on your feet and it will help you breathe better and sleep better.
There was this story going around a while ago. I don't know if it's true because I've never tried it, but if you rub garlic on your feet, you'll wind up getting garlic breath.
Well, it depends on how much you lick your feet, I suppose. Yeah. But I mean, it's been told to me that VapoRub on your toenails and things can actually help fungus, clear up fungus.
Oh, probably kill anything there.
Yeah, I know. But I mean, I don't know if it's true. But the thing is about your breathing, about you having a good sleep, how does it work out? Why not just stick it on your chest? Why not on your feet? And then you put your socks on top of it. So it makes your socks rather smelly and oily. But it's not going to get into your bloodstream, right? It doesn't get into your bloodstream on your chest. It's something you breathe. But I mean, well, why the feet? It's a strange thing, but I'm sure there's actually every other part of the body you can rub VapoRub. It hasn't actually been suggested that it actually can have problems associated with it. Yeah, skin irritation, headaches, dizziness, confusion, and hallucinations if you use camphor inappropriately. So it's not a totally benign product, but sits there in your medicine cabinet for 35 years. But hey, there's a lot of things in the back of your medicine cabinet you probably shouldn't be using.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.